we are on a fast track to climate disaster. It's time to stop burning our planet and start investing in the abundant renewable energy all around us.
Hello everybody. What do these dramatic statements from UN Secretary General Antonio Guterres have to do with the IEA Solar Heating Cooling Task 66 solar energy buildings? This question I would like to address to the task manager Harald.
Hello Claudia, thanks for the question. On global level, the operation of buildings accounts for around 40% of the primary energy consumption and 25% of the greenhouse gas emissions. A significant amount of these emissions can be saved by a reduction of the non-renewable energy consumptions of buildings. One excellent way to do this is to use solar energy to heat and cool our buildings and also to produce the electricity required by the buildings. Hence, the overall goal is to implement integrated solar energy supply concepts for solar energy buildings as the basis of the city of the future.
And what do you within the Task 66?
Within Task 66, we further develop and implement solar energy buildings. To do this, we work on the definition of key performance indicators. We also work on a lot of dissemination activities. We implement and analyze demonstration buildings, and we also look on technologies and system solutions for solar energy buildings.
Thank you, Harald. And Frank, you're the leader of Subtask A, where you are focusing on topics as boundary conditions, KPIs and definitions. So can you tell us, what are you doing exactly there?
One of the major activities of our work was to create key performance indicators for solar energy buildings. A long list with many different of those shortly called KPIs in the fields energetic, technological, economical, ecological, up to sociological is available now. The KPIs, one prominent example is the solar fraction, can be used to describe, to evaluate and to compare buildings, building blocks up to communities. On the picture, you can see all the energy flows which occur in building. All the KPIs can be easily tracked and can be understood and used. And some of them are used also for the simulations in Subtask B and C.
Frank, you mentioned the KPI solar fraction. Could you please explain this very important variable to us, Harald?
The solar fraction provides information how many percent of the total energy demand of the building required for heating, cooling and electricity is supplied by solar energy. What is extremely important in this context is the fact that we calculate the solar fraction based on a 15-minute time interval and not on an annual basis. By using this 15-minute time interval, our solar fraction directly corresponds to the CO2 savings that can be achieved by the specific solar energy systems.
Thank you, Harald. Welcome also to Alphabet. As one of the leaders of Subtask BC, you definitely can tell us more about the outcomes. What are your activities?
One of our main activities was gathering demonstration cases. There are 21 demonstration cases included in the investigation from Europe, Asia and Australia. The used technologies appear in the table, and the most popular ones are PV collectors, solar thermal collectors, electrical batteries, batteries for electrical vehicles and hot water storage. The solar fraction is low in some countries, and this is because some countries have a high degree of renewable in the electrical and thermal grids. Therefore, some systems are designed for low solar fraction, and this is not reflected in the numbers. Here you see some pictures of the demonstration cases.
Alphabet, you also have conducted a study on a very important target group. what do stakeholders find most important regarding on solar energy buildings?
We made a stakeholder survey, and most stakeholders find the mentioned aspects very relevant, especially reduction of CO2 emissions and suitable national legislation. Regarding the performance of solar energy buildings, stable rules on selling electricity to the grid is considered very important, especially in countries with highly variable electricity prices like Denmark. And regarding local production of components, Mexico stands out with great focus on local production, while Danish stakeholders don't find this point important at all.
Thank you, Elisabeth. Harald, and how does the Task 66 address these technologies specifically for solar energy buildings?
We addressed solar energy building technologies by two main approaches. The first approach was that we collected more than 100 buildings and analyzed them with regard to the different technologies that were used. The second approach was that we did a survey of current and future technologies and components for solar energy buildings within Subtask D, led by Michael Gumhalter.
Yes, Michael. In your Subtask D, you are focusing on current and future technologies and components. So what would you say? Which components are typically used for solar energy buildings, and is this really available on the market right now?
In our case studies, we found a large variety of technologies that are currently used in buildings to capture and store solar energy. Among the most common of them are, of course, the photovoltaic systems together with electrical storages. And on the thermal side, we have the typical solar thermal collectors together with hot water storage tanks. As the whole field progresses, also hybrid technologies like PVT or also multifunctional components for building and renovation play a larger role. These could be things like thermally activated facades, which allow the generation and storage of thermal energy at the same time. Looking forward, in research, there is a large focus on advanced storage technologies like thermochemical storages or also phase change systems. These systems, they promise longer storage durations and also higher energy density. In combination with advanced control strategies, these technologies promise an increased solar fraction and therefore an overall more sustainable solution.
That sounds very interesting, Michael. And how can I learn more about those technologies like phase change systems? And what about stakeholders? How are they informed?
To get an overview of what's currently available on the market and what's also in research right now, we have published the Tech Radar you have seen earlier, together with a large market potential analysis. And for some certain selected technologies, like the phase change systems, we also have fact sheets that are collected and published within the task.
Now that we have gained an overview about the results and the activities, how will the findings be disseminated, Frank?
One of the activities of my subtask is dissemination. Besides the publications of the scientific results of all the subtasks here, A, B, C, and D, we created 2 promotion brochures. One for the target group investors and the other one for the target groups politicians, municipalities, utilities, and energy-related companies. As an example, you can see now the front page of the investors flyer. All necessary information is condensed, but clearly and comprehensively summarized on 4 pages. On the first page here, you can see the advantages of the solar energy buildings are given with which result in the simple formula, solar energy buildings equals money saving.
Thank you. That really makes me very curious and sounds very promising. Thanks to all subtask leaders for the insights you've been given to us. And is everything done now? And would the world be saved, Harald?
Nearly, Claudia. But I think we should not end this final task video without addressing 2 important aspects. First, I would like to mention that all deliverables and publications produced by Task 66 are available on our Task 66 website. And the second aspect is that I would like to thank everybody who contributed to the success of Task 66, and these were really a lot of people. We hope that with all the work that we did within Task 66, we can contribute to make the building sector a bit more greener and a bit more sustainable by implementing more solar energy buildings, because this is for sure the future.